So on Friday, we talked about our two special right triangles. Now, all your assignment on Friday came from just the one special right triangle, the 45, 45, 90. Today, your assignment will come from the second special right triangle, 30, 60, 90. But they are worked the exact same way. That's why I gave them both to you on Friday. The way you work them, the way you approach these problems is exactly the same. Why do I tell you those shortcuts as far as those similarity numbers? Well, I do that. This is 1 square root of 2, and the other one is going to be 1 square root of 3, 2. I do that because I find it far easier to remember those two number patterns as opposed to trying to remember those three formulas. Okay, because some people get confused by the formula. Well, if you use the number patterns, you can set up similarity and work from there. That is very handy for a couple of things. First off, those of you taking the ACT allows you to have a calculator. No formula sheets. So you need to know your math. Okay? And one great way of knowing your math is trying to find out the shortest or easiest way to memorize big information. And this is one of those. Remember 1 square root of 2, and please remember 1 square root of 3, 2. Okay? How would you know which one of those goes with which triangle? Anybody have an idea on that? If all I do is remember those two number patterns, how do I know which one goes for the 30, 60, 90 and which one goes for the 45, 45, 90?
Smallest and greatest.
Okay, but how do you know which triangle it goes from? I mean, they're listed small for like smallest side to longest side. I agree with that. How do I know which one goes for the 45, 45, 90 and which one goes to 30, 60, 90?
45, 90, there's two of the same number, so it's like 1, 1.
That's exactly it. You know that 1 square root of 2 has to go for the 45, 45, 90 triangle because 45, 45, 90 is going to be an isosceles right triangle. So it has to have two congruent side lengths, right? Exactly. See, if all you do is memorize those two number sets, you have more information than just that already in your head. Okay? You don't have to sit and memorize three formulas and how they work and when they work and all that kind of good stuff. Just memorize those number sets. Okay? On the NISA, when you guys are juniors, you're taking the NISA state test, they give you these, basically this right here. They give you the triangle, the pictures of the triangles. I don't think they give you the formulas. They might, but I'm not sure. But they definitely give you the picture of the triangles. The issue is they give them with variables in there, like they do here. They give S's. On that NISA sheet, it's actually X's. They give you all X's on there. I don't care for that myself because I think it gets confusing. I'm solving for X and this says X. Okay? So what I do, how do I get these numbers? Is I just plug 1 in for X. Or in this case, that's how I got them on Friday for you, is I plugged 1 in for S, and that then produces my three number pairs. Okay? So once we have these, once we've memorized these, now we want to work with these. So I want to do an example on the back of your notes here because we did some of these on Friday already. So let's look at the back of your notes here. And I want to look at that last problem, that jewelry making problem. Because this problem actually holds a lot of information, a lot of review for us that is all very good review. Okay? In your notes, meaning your previous notes, last semester's notes, I can't off the top of my head remember which section it was, but I do remember we were talking about isosceles triangles, so it was towards the later part of the semester. And we had a couple of theorems from the book that I kind of condensed into one nice, easy theorem to work with. Okay? And I have that theorem written on the board here for you. It says, and you can rewrite it in your notes, that may not be a bad idea since you probably don't know where it is in your other notes. But in an isosceles triangle, this is a property of isosceles triangles that you need to remember, folks. In an isosceles triangle, if a segment drawn to the base is either an altitude, which means it's perpendicular to that base, or it's a median, which means it cuts that base in half, or it's an angle bisector, which means it cuts that angle in half. If it's any one of those three, it's all three. Okay? If it's any one of these three, that means it's all three. That is a property of isosceles triangles we talked about last semester. So how does that help us in this problem? Well, they say that we are making a pendant in the shape of an equilateral triangle. What does that mean, equilateral triangles?
Also
All three sides are the same length. And it says that the height of each pendant is going to be 18 millimeters. We want to know what is the length of each side. Okay? So, looking at this diagram, we are given an equilateral triangle. Okay? And because it is equilateral, we know certain things. We know that all three sides are the same length. So this is going to be S, and this entire third side is going to be S. Okay, I'm not going to write that in yet. But that entire third side is going to be S. And if a triangle is, again, thinking back first semester, if a triangle is equilateral, it also means what? It's got to be what? Equiangular. Well, what does that mean about its three angles? So they're all congruent. That means they're all 60 degrees. 180 degrees divided by 3 is 60 degrees. So this is a 60-degree angle. And this is a 60-degree angle. And again, I'm not going to write the angle on the top quite yet, but we know it's 60 degrees. Okay? So we know that information so far about them telling us it's an equilateral triangle. Well, now, they said that we're talking about the height of that triangle, the height of that pendant. Well, that height is actually called an altitude. If you look back at what I have written on the board, an altitude is perpendicular to the opposite side. That's exactly what we have. So since it's an altitude, that means according to this theorem I have on the board, it's also a median, meaning it's bisecting that opposite side, and it's also an angle bisector, meaning it's bisecting this angle. Well, that tells me a couple of things. That tells me that this side length down here, each side length here is half of whatever S is. And it tells me that those angles up top are 30-degree angles. It's a lot of information. We would not be able to solve this problem without that information, or at least some of that information. Okay? So this is a very important theorem to know. And again, those of you planning on taking the ACT, you need to know this property. Okay? That comes about a lot. That comes about a lot. Okay, so we now have this setup. That means that I can look at one triangle, specifically this one. Looking at that triangle, I know it's a right triangle. In fact, which type of right triangle is it? It's a 30, 60, 90. Since it's a 30, 60, 90, I know it's going to be similar to a triangle that has side lengths of 1, square root of 3, 2. Any questions on our initial setup? So now that we have this set up, now we know this extra information, we can then solve for our side length by setting up our proportion. So we have 1 square root of 3, 2. Please remember that in isosceles, or I'm sorry, not isosceles, in 30, 60, 90 triangles, all right, in a right triangle, there's always one hypotenuse, right? Yeah. Well, in a 30, 60, 90 triangle, the other two sides, or actually any right triangle, the other two sides are called legs, right? In an isosceles right triangle, the legs are the same length. But in a 30, 60, 90 triangle, and actually any other right triangle, the legs are different lengths. And so, of course, we're going to call one of them the short leg and one of them the long leg. Please don't get confused. When I say long leg, I'm not talking about long side of the right triangle. Because the long side of the right triangle has its own name. It's the hypotenuse. Okay? I'm only talking about the legs. Short leg versus the long leg. And remember, we talked about this last week as well, that the short side or short leg of our right triangle is always going to be opposite the smallest angle. And our longest side is going to be opposite the largest angle. So looking at this, to plug in my shortest side, which is going to be my shortest leg, what would I put down here? What is the shortest leg? 1/2 of S. Okay? Then if you get confused with the whole long leg versus hypotenuse thing, we should all be able to identify the hypotenuse as the longest side of our triangle. Well, what's the hypotenuse of that blue triangle? So that goes under the 2. Right? And then we can just fill in the blank for that middle length side. But that middle length side is actually called the long leg. And the long leg is opposite the 60-degree angle. Okay? And that long leg, they tell us, is 18 millimeters. Well, all they asked us to find is S. We don't need to find half of S. Right? But we get the option now. Would you rather work with 1/2 S and that fraction, or would you rather work with just S? Yeah. If I'm solving for S, I would rather work with just S. So I am going to use this proportion. Cross multiply gives us S square root of 3 equals 36. And we want to solve for S by dividing by the square root of 3. Now, could we rationalize that answer? Yes. Could we write it in simplest radical form? Yes. Did they ask us to do that? No. So we grab our calculators, and we simply need to take 36 divided by the square root of 3. I get 20.8. Did you get the same? Not hearing any answers. Nobody got that? I'm seeing a couple shakes of heads. Okay, yes, people got that. All right, good deal. All right, well, the majority of your problems today in your homework are not going to be story problems like this. Okay, there will be a few of them, but not story problems like this for the majority. So what you're going to have to do for the majority of your homework is work with problems that simply say, given this triangle, solve for the 2 missing side lengths. Okay? So again, let's simplify the problem. Let's get rid of the whole pendant and equilateral triangle stuff. Let's just solve this problem. What type of triangle is it? 30, 60, 90. So therefore, what number shortcut do we use? Say that again. 1 square root of 3, 2. 1 square root of 3, 2. And we're going to put those at the top of our proportion. Well, now for the bottom of our proportion, we put in the numbers from our triangle. What is the short leg of our triangle here? X. What is the long leg of our triangle here? Y. And then what is the hypotenuse? 6. Always reduce fractions before you use them, if possible. Well, it's possible in this problem. I can reduce 2/6 into 1/3. Okay? And so now I can solve 1 over x equals 1 over 3. You guys probably already know the answer, otherwise cross multiply gives you the answer. X must equal 3. Okay? And then I also want to solve the square root of 3 over y equals 1 over 3. Cross multiplying that guy gives me y equals 3 square root 3. Questions on solving a problem like this? Again, it is the exact same setup as we had on Friday with 45, 45, 90s. The only difference is what numbers do you use for the top of your proportion. If it's a 30, 60, 90, you use 1 square root of 3, 2. If it's a 45, 45, 90, you use 1, 1 square root of 2. Okay? Look back at your notes for that, for which one you're using. But once you have that figured out, the rest of the problem is done the exact same way. Okay?